Good evening, everyone. Welcome to 3D Experience Workshop Day 5. Today, we are going to cover the topic Surface Design Workbench. So, the session is over to Mr. Nagarjun, the speaker of the workshop.
Good evening, everybody. So today we are going to cover 3D Experience Workshop, Surface Design Workbench, and I am Nagarjun Bhaskar. I am Senior Application Engineer at Altum Technologies. Before we go ahead with the session, I would like to tell about my company, Altum Technologies. Altum Technologies was established in the year 2010. We are operating from 8 different locations in India. We are having an experienced team in the business of engineering, simulation, PLM solutions, additive manufacturing, reverse engineering, and optimization solutions. We are gold partners of Dassault Systems. We are certified and we have experienced technical staff for pre-sales and post-sales activity, engineering consultancy, and we do provide authorized training. Altum has more than 250 customers for additive manufacturing, engineering simulation, and PLM solution. Apart from Dassault Systems, Altum Technologies is also partner with MSC Software. MSC Software has around 17 softwares under their umbrella. All of their softwares are related to the analysis. So, mechanical analysis. They are having solution for each and every domain in the mechanical analysis. For example, they are having Adams for multibody dynamics. Okay, the similar manner. Next, we are partners with Stratasys for FDM 3D printers, Polyjet 3D printers, and SLA 3D printers. Next, we are also partnered with a company called Artec 3D. They are into the business of manufacturing 3D scanners. Apart from that, we are also partnered with a company called Cellink. They are into the business of manufacturing 3D bioprinters. So, what does Altum do? If you can see in the mechanical product cycle, we are having specific solutions for each and every area in the mechanical domain, from conceptual design till aftermarket. For example, if we take the area of engineering in mechanical domain, we are having specific solutions related to the design software from Dassault Systems. Like we have CATIA for design software, and we have got 3D printers from Stratasys. And if we come for tooling, again we are having design software, that is CATIA V5 from Dassault Systems. We are having 3D printers and 3D scanners. Okay. So as you can see, we have also received many prestigious awards. Okay. This is the partial list of our customers. So what is this 3D experience platform? This is very important because today we are going to cover about the surface design workbench in 3D experience platform. So just a small introduction, I'll not take much time. So what is platform? Platform is a customized environment where multiple process applications are integrated to perform multiple tasks. If you see on the screen, suppose say 15 to 20 years back, if you wanted to click a picture, you would have a separate hardware called camera with which only you could click pictures. And if you wanted to listen to songs, you would have iPod or Walkman. And if you wanted to access Gmail, then you would need to have a desktop and you need to have internet connection. Then if you wanted to listen to okay, those are the things. So all were separate, what do you say, working separately. Integration between all these things was not possible. So what I mean to say is, if you wanted to click a picture, okay, and if you wanted to make a collage of the pictures, and if you wanted to share it with your friends in the group, it would be a very difficult task. You would need multiple hardwares, wires, connections, and everything. And in the process, the quality of the photo would have drastically reduced. Okay, and integration was very difficult. Similarly, if you can compare this with the mechanical industries in current scenario, there are many areas, okay, with respect to design field. Conceptual design softwares are available, 3D modeling softwares are available, FEA, finite elemental analysis softwares are available, tooling design software is available, PLM, product lifecycle management softwares are available. Each one of the softwares are non-integrated, okay, and working together as a team is very difficult. So what is the problem with the non-integrated application? Okay, suppose say if we take example the offerings from Dassault Systems. Dassault Systems has CATIA V5 for modeling, and they have Simulia for doing simulation. If you create a part in CATIA V5, if you save it, the extension of the part is .cat part. But if you see the Simulia software, the input to the Simulia software cannot be a .cat part. So the .cat part file needs to be converted into a native data format, that is either STL or IGS. And that IGS or step file can be an input to the Simulia softwares. During this process, whenever you convert the .cat part to the native data format, there is data loss. Okay, and which is not a professional and which is not recommended. So the companies will face some losses. With 3D Experience platform, everything is interconnected. No need to convert to the native data format. The PLM software is designed in such a way the direct cat part or directly the file from the CATIA can be integrated and opened in the Simulia. No history is maintained like life cycle state, revision, modification, data location. So each department in the company will have the same file, but each person will have different revisions of the same part. Tracking that and maintaining and ensuring that all the departments are having the updated design or updated parts is a very difficult task. In 3D experience, because it is a single unified platform, it is always updated, and we can be absolutely sure that each and every department are having the updated files. Okay. Similarly, it is very difficult to estimate project completion time, and it is a nightmare for the project managers. But with 3D experience, you can have the overview of the project and in a single window, and you can able to take better decisions, and the product will launch to the market much faster. Okay, and the still list still goes on. So what Dassault Systems has done is they have integrated all their offerings into one platform. They were having a software called Enovia, which was for project management. They have made Enovia as their base platform, and all the SolidWorks, CATIA, Geovia, everything. If you see 3D Swim, everything will be available on the platform. It will all be interconnected. Okay, and the last, if you want to say that 3D experience offering is provided by Dassault in two variants. That is, you can choose whether you want to go on premise or on cloud. If you choose to go for on premise, the company should maintain its own server, and they have to maintain their own database. Okay, but if you go choose for on cloud, Dassault will maintain the server and Dassault will maintain the database. So the company need not have to invest heavily on the hardware, and it is very easy for the companies to work. Okay, so with this background, I would like to start our surface design session today. Okay, so if I go, these are all my licenses and these are all the workbenches. Depending upon the license which a user is assigned, he will be able to access the workbenches. Okay, so here I will go for generative wireframe and surface. Okay, before starting, if you recall, for part design, okay, all the features were sketch based features. That means before using the part design feature, you must have a sketch. You must develop a sketch, and you can perform the operation based on the sketch. In the similar manner, if you want to develop a surface, we need a wireframe. Okay, so it is like part design requires sketching, surface design requires wireframe. So just I will start with the wireframe. What are all the options available, and how we can create the wireframes from which we can develop the surfaces. Okay. So you can build a surfaces using sketching also, but apart from sketching, there are some wireframe options by which you can create the surfaces. The first one I would like to take is the helix. Okay. What I will do, I will create a point on the XY plane. Okay. I'll click on the helix. Okay. The helix has three parameters: pitch, revolution, and height. So we can able to manage the helix, the construction of the helix wireframe by giving two inputs. Either we can give pitch and revolution and the height is automatically calculated, or we can give the height and pitch and revolution is automatically calculated. Okay. And I'll use starting point as the point which I created. Axis I'll give a Z axis. Okay. Now I will go for pitch. I'll go for 5 revolutions. If you can see, the wireframe helix has been created. You can change the orientation from counterclockwise to clockwise. Okay. And you can give the taper angle. You can see this is inward taper and this is outward taper. Okay. Sorry. Okay. What I will do, I will draw a sketch here. Okay. I'll come out of the sketch. I will click on this helix. Okay. What I will do, I will delete this helix. I will select the helix. I will give the starting point, Z axis. I'll give like 20 mm and I will give us 5 revolutions. Let's see. Okay. Now it is asking for a profile. I will select this profile. The origin is not on the profile. Okay. Okay. If okay, this point now, what I will do, I will give it as 0. Okay, now it will work. First point, Z axis, some 20 mm, some 5 revolutions, and now I'll give it. If you can see, the okay, I will give height and pitch. Okay, it is trying to follow the. If you can see, it is trying to follow this profile. So if you want a spring to follow a certain profile, it is possible. Now I will hide this. Okay. Now what I will do is I will show you how you can build a surface using this wireframe or the profile. I will create a plane. Okay. Normal to the curve. Okay. Select this curve and I will select this point. Okay. I will take a sketch on this plane. Okay. And I will draw a small circle. I will give coincide. Draw a small circle. I'll come out, and there is an option called sweep. We will get into that. I will explain you the complete sweep option. Yeah. I'm not able to find the sweep option. Sweep. Okay, with reference surface, I'll click this and I'll click this, and you can see a surface is formed. Okay, I will hide this wireframe. Okay, now I will go to the, I am in generative wireframe design. I will go to the part design workbench. Okay, and there is something called as closed solid. We can convert this surface into solid. Close surface. I'll click on the surface and I'll click OK. Now I will hide this surface. Sweep. Okay. Now if I go to review and if I go for section, you can see this is a solid. So this is how you can create a surface and you can close it to make it a solid. Okay. Let me delete all of this. The second one is the spiral. So what I will do, similarly, I'll create one more point on this XY plane and I will go on the spiral. It is asking for the support. I'll give as XY plane. It is asking for the center point and it is asking for the reference. So it is not possible. It is center point as this and reference direction as Z or reference direction as our Y because this is 2D. And in the same way, there are angle, pitch, and radius. Okay, and we can create the spiral. Okay, this is the spiral option. This is one more way of creating a wireframe. Okay, on the similar line, there is isoparametric curve, which I will be covering later. Before this, I would like to show about this combine. To show this combine option, I have an example. Okay. Okay. So if say suppose you want to draw these curves on a bottle, these grooves on the bottle. Okay. So what I will do, I will first take a uh, sketch on the top plane. I will draw a circle. I'll just come out and I will extrude it. I will go through this one by one slowly, but okay. I will click on this. Now I will go and I will make a surface on the front plane and I will take a spine. I just saw some random. For example purpose I am doing. Okay. And I will come. Now what I will do is there is a command called combine. What I will do is select this as curve 1, select this circle as curve 2, and I'll give preview. If you can see, now if a wireframe is created. What is the logic? If I go and if I view it in the front view, you can see it is following this sketch 2, and if I view it on the top view, it is a circle. So it has combined both of them. Okay, the requirement or the prerequisite is both the sketches must be normal to each other. Okay. Now what again I'll do, I'll take a point on this curve. I will create a plane normal to the curve at that particular point. Okay. And I will draw a small circle on this plane. Okay. And then I'm going to sweep it. Okay. Now what I'm going to do is I'm going to hide this. Now I'm trying to make a groove. Okay. So there is something called as split and trim. I'm going to explain you in detail regarding that. But as of now, I'll try to explain you split and trim. I will do trim. I'll select this surface and this sweep surface. Okay. And other side, if you can see, just click OK. Now the groove is done. This is how you can design this groove, which you can see on the distillery bottle here. Okay. So this is how you can use the combine option to get this kind of groove. Okay. So let us move on to the next one. I want to explain you about the projection. Okay. Say suppose I take a sketch and I will draw a spline. Okay. And I will extrude this. Okay. I will take a plane, offset it. Okay. Offset it. And I will draw a circle on that plane. Okay. Now I will hide this. Okay. Now I will extrude this circle. Okay. Now I will do a split operation. Sorry. You can see there's a circular hole. Okay. But what happens if I do projection? I will project this circle onto this plane. You can see it is coming as a ellipse. It is not coming as a circle. So this is what the projection will do. It will try to adapt to the shape of the curve. Okay. It is circular, but it is taking the shape of the curve. Hence, it is appearing to look like an ellipse for us. Okay. This is where like you can use the projection command. Okay. Next, I would like to show one more thing. Okay. So suppose there is a random point somewhere. I will give some 100, 250. There's a point somewhere here. Okay. The point is here. I'll delete all of this. Okay. So this is one point. I'll create one more point just on the ZX plane. Now these 2 points are in space. Now what I will do is I will take a line and I will give it a Z axis. Okay. I'll create a line. I'll get a Y axis. Now I want to connect these two lines. Okay. So there is something called as, let me look at that option. There is an option called connect curve. So this is the first point and this is the first curve. This is the second point and this is the second curve. See, if you want a reverse, you can. So this is a 3D curve. Okay. So you can change the direction of the tangency. Okay. You can change the tension. Okay. And you can connect these two curves in 3D. Okay. This is connect curve option. Okay. These options are will be very useful while you're working with the surface design. Okay. This is the vectors. Okay. Can give 0, 0. Or I can give 1. Sorry. 1 and 1. I think the tangency should be opposite. Okay. This is the connect curve option. So these are some of the important wireframe features which I wanted to uh, highlight and show here. Now let us go through the surface creation features. Okay. As you saw, the first one is the extrude. You can create any open profile. Before showing this command wise, it is better like I show it with an example. Okay. So it will be very helpful for you to understand in a better way. Okay. So let us try to create this part using surface design workbench. You might all be knowing why do we require a surface design to create this. There are no surface features. This can be easily achieved in part design. Actually, this is not a surface part. This is a part which is developed in surface design. Just for our workshop today, just for our example, I wanted to show you like how we can use the surface design to build a model. What is the methodology? Here you will draw a sketch, you will pad, you will make a hole, you will make a pocket. Okay, you will do all sorts of things which we discussed in part design. But our approach of creating this part in surface design will be completely different. The way you have to think and the methodology you need to follow is completely different. This is what I'm going to explain you today. So here, now what is the start? How do we start if we have to design this in surface design? First, I'm going to develop this surface, which you are currently seeing, which I'm showing with in my mouse. Okay, this front surface, only this front surface. So I'm not going to draw to scale. I'm just going to draw rough dimensions, so that in interest of time. Okay, so what I will do is, okay, okay, let me draw this, and I will mirror this. Okay, now I will draw a 3-point curve. First point and the second point. And I'll come out of the sketch. Now I have drawn this sketch. Actually, I should have drawn it in the left hand side view. Okay, this is correct. Now I will do fill. There is a option called filled in the surface design, and I'll fill the sketch. You can see my first surface has been now created. We have to make sure that all the surface design we need to do it under geometrical set. Okay, we must not do under part body. So what I will do, I will create a geometrical set. I will cut and paste it in the geometrical set. Okay. Now I will hide this sketch. Okay. Our first surface is now ready. I need a similar surface, okay, at a distance of 36 mm. So what I will do, I will go to the transform and I will translate it. I'll select this. I'll select this direction. I'll give it as 36 mm. Okay. Minus 36. Okay. Now, actually, I'll give it more so that it looks to scale. I will give around 100 mm. Okay. Now I need to create the top surface. So what I will do, I will draw a line between these two. This is also part of wireframe, okay, and I'll draw two lines. Now I can fill this, okay, or I can use extrude. So what I will do, I'll go to tools, I'll measure this length. Okay, from this point to this point. I'll keep this length. Okay. Now I will come for extrude. I can select any open profile, give the direction, get extruded. What I will give length 217.568. Okay, and I will hide this. So now this top surface is formed. Now what about this side surfaces? I'll again draw one more line between these 2 points, and I will use fill. I must select all the edges. Okay, and I will fill. I will take one more line and I will fill. And I will fill this. 1, 2, 3, and 4. Similar way, I will draw last line and I will fill this. 2, 3, and 4. Okay. Now I will mirror these three surfaces. Okay. Transform and mirror. Symmetry. Yes. Now the surfaces are formed. Now you can see each one of is a if I hide this one, only this is hiding. So each one is a different surface. I will show you. We can join those. First, let me complete it. There is some small things pending. Okay, and I will fill up this. 1, 2, 3, and 4. Last line here and here, and I'll fill it. 1, 2, 3, and 4. Now I'll fill up this 1, 2, 3, and 4. Okay. Now all the surfaces have been generated. Okay. Now I need to make this as one surface. Okay. So there is a operation or command called join. Click on this. I will click on one surface. I will right click and I'll get distance propagation. If you can see, there is a what is the value called merging distance. Okay. If there is a gap, okay, which is smaller than 0.001, it is going to ignore. You can create this point as 0.01. So if there is a gap of less than 0.001, it will ignore this and it will create one surface. Okay. Now if you see, okay, so it is became one entity. Okay, this is done. Now what else is remaining? There is a through hole on the top. I will draw a circle here. Or without going into the sketching, there is an option called circle. For that, what I will do, I will delete this. I will take this circle. I will draw a point on surface. Okay, and I'll give a zero value. Oops, something is wrong. Surface is this extrude, and I'll give value as 0. Okay, a point on the center of the surface is formed. I will go to the circle. Remember, I'm not going into the sketching. You can do it in sketching, and you can do it in wireframe also. There are multiple ways as to how you can create a circles here. I'll create center and radius. Center. Okay, this is the support, and I'll draw full circle. Okay, I'll give radius, whatever value I want. I'll click on OK. Now what I will do, I will extrude this both the ends. Okay. Before this, I would like to explain what is split and trim. Okay. I will show you in a separate what is a part so that it will be very easy for you. What I will do, I will draw one line and I will extrude it. Okay. I will take one more sketch. Come out and I will extrude it. Okay. Now there are two operations. Please concentrate, is very important. One is split and one is trim. Let us understand one by one. First, I will go for split. What is split? It is like you want to cut one surface with respect to another surface. It lasts two elements: element to cut and cutting element. It is like, you remember, you are having an axe and you are having a tree. So element to cut in this case is you want to cut the tree. So you're going to select a surface which is going to get cut. I want to cut this surface. With respect to which is your axe, the second surface is my axe. You can see that surface is now deleted. But remember, this is a very good feature in CATIA V5 or in 3D Experience. The other systems has thought very carefully. Once you create a surface, okay, unless until you delete, the surface will never get deleted. It will just be hidden. So our surface, if you go to the hidden workspace, okay, it will be available. Okay, see, I am not doing this in the geometrical set, and that is why it is very important for us to always follow the norms as respect to how it should be on the tree. Okay, now I will hide. Sorry, I haven't performed this, but I'll define the split. Click on. Okay, I will cut this element with respect to this and I'll click OK. Now if you see, the split has happened. If you go to the hidden workspace, you can see the full surface. If I unhide this, you can see both the surfaces. Okay, if you go to the workspace and unhide this. Okay, so no matter what, the surface will never get deleted. It will just get hidden. Okay, now Sorry. Okay, now I will reverse this. I will make this as element to cut. So I will reverse. Reverse is also possible. Cut this surface with respect to this surface. Okay. Now I want to cut this surface also now. I will perform on one more split. This time I will cut this with respect to this. And you can see. Okay. So this is about the split. Now what is trim? If you go for trim option, okay, there is no cutting element and element to cut. You have to select two surfaces. Okay. Now if you can see, this trim is equal to double split. Whatever can be achieved using split two times, the same thing can be achieved with trim in a single command. This is the major difference between the split and trim. I hope like you understood. Here in trim you have various options which portions you want to retain. If you can see, I am changing the options here and I am getting various results. Okay. So this is the split and trim command. Here I will show you. I will use the split command. Now in our case, our element to cut is this solid. So what I need to do is I need to hide this, make this into a complete solid. Okay. And okay. Now I will split this with respect to this. And I will hide this, you can see. But now this cannot be converted into solid. Okay. So what I need to do is oh yeah, what happened? I'll extrude this. Okay. I will split this with this. Okay. And I'll unhide this. Now this cannot be converted to solid. So I will now split this cylinder with respect to this. And sorry. Here we need to change this. Now if you can see, this can be converted to solid. Okay. So instead of two splits, we can achieve the same result using trim. This one and this one and other side. Okay. So this is what I was talking about. Double split is equal to trim. Now what I will do, I'll go to part design workbench and I will go for this close solid. Okay, I will hide this trim. And now if I go for review, it will be a solid. Okay. Now I'll go back to the, I'll delete this close surface and I'll go back to the surface design workbench and hide this trim. Okay. I hope until now it is clear. Okay. Now I want to make this cutout. So what I will do is I will go and I will select geometry tools, select workbench. Okay. I will go here and I will want to draw a sketch here. Okay. So what I will do, I will draw a rectangle. Remember that you have to draw something outside the required cutting area also. Okay. And I will extrude this. to whatever length I require. Okay, and what I will do, I will hide this and I will fill this. 1, 2, 3, and 4, and I will join these two, extrude and fill. See, the join operation will work if you don't want any surface to be part of your join. You can hide those surfaces. Okay, now only these two surfaces are, what do you say, in the show space. Everything else is in the hidden space. So the only these two surfaces. I click on join. I'll click on any surface. Right click, distance propagation. Whatever the surfaces are present in the show space and whatever the surfaces are connected to each other, only those two surfaces will be joined. Okay. Now I'll unhide the strip. Okay. Now either I need to do double split or trim. So I'll go for trim. Select these two surfaces and I'll see. I will hide this. See. Okay. Before doing this, since we want to do it on both the ends, I will mirror this joint. Okay. Now I have to perform trim on both the sides. This surface, and trim on this and this. Okay. So now our part is ready. This is how you can build this solid or build this part using surface design workbench. Then you need to convert this into solid. As I have shown you, now this is a surface. If you want to see, we'll review it. This is a surface. Remember, surface does not have any thickness. Okay. There is one more example. If you want, you can convert this into a solid, but it is not closed solid. So you can give thickness and you can make this into solid. So go to part design, model, and you can give thickness to the surface. Okay, just give 1 mm thickness. I will hide this trim. Now this became a 1 mm thick solid. You can see the thickness of this is this space and this space is 1 mm. Either you can add thickness to the surface or you can close the surface, make it into a closed surface, and you can directly convert into a solid by using closed solid command. These are the two ways how you can convert a surface into a solid. Okay. I hope like this is clear. Okay. Now let us. I want to explain one more thing here. Okay. I will draw a spline. I will come out and I will extrude this. Now I want a wireframe on this surface. I will go for this and I will go for this. Sorry. Isoparametric curve. I'll just click on this, and if you can see in X and Y direction, you will get a wireframe. And move this. Okay. You will get this wireframe. Okay. This is one of the ways how we can create a wireframe. This option is called isoparametric curve. It follows the surface. you hide, you will get this butterfly. Okay. Now before this, okay, I will extrude this surface. Now say I want to extrapolate the surface. I want to what do you say? Need extension of the surface. This option is called extrapolate. Where is it? Okay. There is an option called. Okay, what I will do? I will press it. Here there will be option called extrapolate. I'm looking for this extrapolate. See extrapolate. Okay. I will select this boundary and it gives me an extension. Now there is something called as continuity. It is very very important. Okay, there are two types of continuity. One is tangency continuity and one is uh, yes, curvature continuity. So what is the difference? Suppose say you are seeing this, I will give length as 100 mm. Okay. Now if I give OK, there is a edge formed between the two surfaces. If you give tangency continuity, there is a edge which is formed. Okay, and this is how the tangency continuity will work. Now what I will do, instead of tangency continuity, I will give it as curvature continuity. You can see now it is a smooth edge, there is no edge form, but it will try to close the circle. Okay, it will try to form a circle. This is the difference between tangency continuity and curvature continuity. Now with this I would like to go here. Say suppose I have got one more surface. Okay, I'll exit the app and I will explore this. Okay, now I want to join these two surfaces. Okay, for that there is an option called blend. Okay, what I will do, I will take this first curve. Okay, first surface, second curve, and second surface. Now here if you see, there is tangency continuity and curvature continuity. Okay. Now what I will do, I will not give the support first curve and I will give the second curve. Now I will join. If you can see, there is no smooth transition between the surface. Okay. If I select first support and if I select second support, and if I can choose whether tangency or curvature and I'll give preview, see how smoothly the surface is trying to join. Okay, and you can change the tension. Okay, okay, or you can change the tension and decide like how you want the surface to be joined. Okay, now you can join these three and make it as a single surface. Right click, distance propagation. So this is now became one single surface. This is how you can use blend to join two surfaces. Okay. Okay. Now let us go through some of the other features as how you can create the surfaces. Okay. Now there is something called as sphere. Sphere requires only one input, that is a center point. Apart from that, no other input is required. I'll just specify the center and the sphere is formed. If you want the whole sphere, you can uh, what is create a whole sphere, or if you want, there are so many parameters. Okay, so this is how you can create a sphere. Okay, if you create a whole sphere, it is completely, see, only the surface. The inside is completely hollow. Either you can give thickness or you can uh, make it full solid. Going into the part design workbench. Now, apart from that, mm, okay, you can exit the sketch and under then there is something called as revolve. Just select the profile and select the axis and see it revolves. Okay, you can give 360 degrees. This is the revolve command. This is how you can create the surfaces you require. Okay, depending upon the requirement, you can use the commands. Cylinder is also very simple, straightforward. I'll just show you. Cylinder also does not require any input other than a point. It just requires a point and it requires a direction. That's it. The cylinder is formed. You need not have to draw a circle, extrude, nothing. Just go to cylinder, give a center point, and give the direction. Okay. What is the next option? What are we left with? See the multi-section surface. It's the same, 100% the same options is available. Whatever was discussed in the part design. Only difference is there the solid was getting created. Here the surface will get created. So I'll skip this as of now. The options are absolutely same. You can refer to the multi-section which was discussed in the part design and you can follow the same procedure. In that solid was being created. Here surface will get created. Okay. What are the other things remaining? Okay, just I will explain you this fillet. This fillet option is really good here. So what I will do is I will take a line and I will extrude it. I will draw one more line and I will extrude it. And I will extrude it. Now there is something called as shape fillet. Where is the fillet? Shape fillet. Okay. What I will do, I will select the first and the second. You need to ensure that arrows are pointing towards each other. Otherwise, the shape fillet option will not work. And I'll give us 10 mm. Let's see preview. If you can see, although these two surfaces are not joined, it will try to create a fillet and it will try to become one entity. Now, if you hide the fillet, it became one. Okay, but you need to ensure that the arrows are pointing inwards and towards each other. Okay, only then this shape fillet will work. Now, what I will do, okay, I will go to the sketch. I will coincide these 2 points. Okay. Okay. Now, these two are two separate sketches. I want to have a fillet between this. So what I will do, I'll try to use edge fillet. But if I give edge fillet, I'll not be able to select the edge. Okay. The reason is those two surfaces are not one single entity. So if you want to use edge fillet, you need to make sure that it is one single entity. Now see, if you join these two, it will become like this. So now it became a single entity. I will unhide this and I will use the edge fillet. And I will give like 5 or whatever it is from the fillet. This is normal edge fillet and this is the shape fillet. Okay. Now one more thing I wanted to show you. I forgot. Okay, here only I will show you. Suppose say I will create a sketch. Okay. And I will extrude it. Okay. Now there is something called as offset and translate. What is the difference between offset and translate? I will click here. I will select the surface and I will take the distance. The surface will get bigger in size. But if you translate this in the same direction, the size of the surface will remain to be same. But if you offset it in the opposite direction, see, the size of the surface also becomes smaller. But translate, again the size remains same whether you move it in x direction or plus x or minus x. Okay, this is our master surface. All these three are same size. But if you see offset, the scaling of the surface also will be happening at the same time. So that is the difference between scaling, offset and translate. Okay. Now what else is remaining? Uh, okay. If you go to sweep, okay, there are 21 different types of sweep available. Actually, I'm not there in the full sheet metal surface design. Okay, I have not assigned myself the complete surface design tool. Okay, so only basic 5 to 6 types of sweep is available with me presently. Okay, so there are three types. One is explicit, line type, and circular type. Actually, if you go for the complete surface design, whatever I am having, the license is basic surface design. In the basic surface design, there is only 5 varieties of sweep. 3 plus 1 plus 1. Five sweeps are available with me. But if you go to the complete surface design, like the full surface design module, you will be getting 21 varieties of sweep. Okay. Now let us explore what is this 5 types of sweep. I have got examples for each of it. I have to import this. Okay. Let me import the CATIA files. Okay. GST training material. Okay. What is the option? It is, I have got examples for all of the surface design. Unfortunately, I don't have the license with me. It is profile with two guide curves, which I'm having the example. Okay, so I will go for this sweep, and this is my explicit with two guide curves. I'm sorry, we need to import explicit with two guide curves. Explicit two guide curves. Okay. Okay, so I will it is fairly easy. So the explicit option, okay, with two guide curves. Here, if you can see, this is my guide curve one, this is my guide curve two, and this is my profile. Here, if you can see in our example, this is guide curve one, this is guide curve two, and this is my profile. So here, yeah, so which is my profile? This is my profile, guide curve one and guide curve two. And if you give preview, you can see this profile has tried to follow this guide car also and this guide car also, and there are options here. Okay, this is the explicit with two guide cars. Let us see what is explicit with pulling direction. Okay, explicit with pulling direction. I got two examples. I'll delete this. Okay, I will go for sweep explicit with pulling direction. So what I need here is one profile and one guide curve, and you need to define the direction. So this is my profile, this is my guide curve, and I'm trying to uh, pull the direction. I'm giving it as z-axis. Here there are four solutions. So whichever is the orange one, that will be my correct solution. So angle I have given as 20 degrees. If I give angle 0, I think there are going to be two solutions. Yes, you can see this is the two directions. If you can provide the angle, it will have four solutions. Okay, see this has rotated also at 20 degrees. This is trying to follow this profile. This profile is trying to follow this guide curve in the y direction at an angle of 20 degrees. Okay, so this is our uh, profile explicit sweep with pulling direction. Okay, there are just two more. Okay, and we can complete this. Sorry, what is the next option available? This is line sweep with reference surface. Okay, let me import line sweep with reference surface. Line with reference surface. Okay, sweep. So what is it asking? It is asking for a surface. I have already got a surface. It has got a guide curve. I have got a guide curve, and it is asking for okay angle. So guide curve and reference surface. I have given angle of 45 degrees, and I given length 1 as 100, length 2 as 50, and it is asking for 4. There are 4 solutions. I need to select whichever I want. This is a line sweep with reference surface has been created. Okay, it's fairly simple. Next, the last one is circular sweep. This is very simple. It's just a center curve and a radius, nothing else. Okay, this is fairly simple. Center curve and radius. I need to draw a line, point and direction. Yeah, line with point and direction, point and direction. Go to sweep and create the center curve, and it is asking for a spine. That's it. If you see the radius of this, it will be 20 mm. Just 20 mm. Okay. So this is all regarding the sweep. So I hope like I have covered most of the things. Okay. There is this is a very big command, surface design, very big workbench, and there are multiple options here. I have just gone through the overview. Okay. So what is the use of this? If you can see, okay, if you can go to the tutorial B. Okay, suppose say you have to create this JCB cabin. Okay, so it is a combination of part design and surface design. You will create a rectangular block, you will create a surface, then you will cut that rectangular block using the surface. Okay, the entire process is explained here. I will just show you. Okay, so you create a pad, you create a surface, you create a split, you do fillet, chamfer. So this creation of this what do you say, JCB's cabin, it requires multiple workbenches. It requires part design and it requires surface design. So both of them can be combinedly used to create the final product. So these you can follow this. This is very easy, step by step they have given, and this is how you must practice and you must learn this surface design command. Okay, I have just given you the overview of the features and the commands. Now it's your turn to practice and get ready and be thorough with the features and everything. I hope like I have tried to cover most of the commands here. Okay, and if at all you need any additional support or additional help, you can contact us and we will try to help and resolve your issues. So I hope like all the 5 days the workshop was useful to you. I have tried to cover all the basic workbenches which is there in CATIA, and there are so many other workbenches available, but those are kind of advanced. These five are like the foundation. The other workbenches will be based on these workbenches. So it is very important for anybody to be thorough with these basic five workbenches. These are the most commonly used, and this will be a foundation for the additional workbenches. For suppose you are going for mold tool design, or you are going for machining design, or you are going for tooling design. So there are different workbenches for different applications. Okay, these five workbenches are the foundation for all the other workbenches. Okay. So I hope like this was a good session and you had a good time, and it was a lot of learning for you. So you can get back to us anytime. We are available, and you can post your questions. You can ask any queries or any doubts, and we'll try to help you. So for today's workshop, if anybody has any questions, I am ready for the question and answer. Either you can type your questions here or you can unmute and ask me the questions. So Nirmal has asked how to surface path line profile. I didn't understand your question. Bhavita, can you mute him, Nirmal, or he might like to phrase the question in a proper manner?
Actually, we don't have option to unmute them.
Okay.
We don't have other questions, so we will wind up the session.
Oh, I think Nirmal can rephrase the question if he's interested. I think I am not able to understand the question. How to surface path line profile? What is that? So Nirmal, if you are there, you can retype the comment. Hello, Nirmal. I think
Yeah,
he's not.
so here we will wind up the today's session. If
Yes.
anyone is having any doubt, you can contact us at inquiry@altum.com. Thank you
You
for
can write.
joining today's session, and you
Babita,
all
you
will
can
be
write
getting
that.
the
You can write that email address in the comment so that people can make a
yes.
note. So this
Thank
is
you
the
everyone for joining
yeah.
the today's session.
Okay. So this is the email address at which you can contact us. So again, thank you for attending the session. Okay, we'll meet soon. Okay, thank you.